Okay, so this is an electrochem question. First up, we have the electrolysis of molten calcium chloride. Whenever you electrolyze something, ionic compound which is molten, right, the only thing that can be discharged is the respective elements, calcium and chloride, in their respective physical state. Okay, so what is the product form? At the anode, we have chlorine gas, and at the cathode, you should have calcium. Okay, calcium metal. What is a non-metal that can be used as an anode? Basically graphite or carbon. Okay, very common. You don't want it to react. A stream of inert gas is blown over the calcium as it is removed from the molten calcium chloride. Any noble gas can be used as an inert gas. Why do we need to blow the stream of inert gas over the hot calcium? Because if it were to come into contact with air, right, then it will react with the oxygen in the air and get oxidized. And that is not what we want. We want the pure calcium. Okay, for B, you have electrolysis of copper 2 sulfate. So they've given you this table, right, with the current use, time taken, and the mass of the cathode before and after electrolysis. So you can see that there is actually an increase, right, of 0.12 grams. Okay, so for each of these two, there is an increase of 0.24 grams. Okay, explain with the aid of a half equation why cathode increase in mass, because copper is reduced. Okay, copper is reduced at the cathode. Okay, that's where reduction takes place. It was observed that color intensity remained the same for the copper sulfate solution. Why is that so? Because copper is being oxidized at the anode is the same rate as the copper being reduced at the cathode. All right, so if it is the same rate, then the amount of Cu2 plus in solution will be the same. In experiment 2, the mass of the anode was also weighed before and after. At the start, it has a mass of 1.45. What is the mass at the end of the hydrolysis? Okay, so for cathode, right, since experiment 2, we increased by 0.24. Here, we should actually decrease it by 0.24 to get 1.21 grams. Okay, they say fourth experiment done 8 amperes 90 seconds. Cathode has a mass of 1.51. So we can tell from here, right, if we use double the current, you get double the mass reduced at the cathode. Okay, but if you also double the time, right, instead of the current, you also get double the mass form, right? So in this case, right, we have double the current but half the time. So each of these factor will negate each other. So end up, right, we will get about a difference of 0.24. Okay, so 1.51, we get some more copper reduced, plus 0.24, you get 1.75 grams.